Hello, my name is Kevin Aaron, and today I will be describing and showing a basic example of Hooke's law. The definition of Hooke's law is that within the limits of elasticity, the strain produced by the stress of any one kind is proportional to the stress. In layman terms, a spring is proportional to the stress on the spring itself. It can be written in the formula, the integral of a to b f of x dx. Example 1. A force of 9 pounds is required to stretch a spring from its natural length of 6 inches to a length of 8 inches. Find the work done in stretching the spring. A. From its natural length to a length of 10 inches, and B. From a length of 7 inches to a length of 9 inches. Before setting up the integrations, we must find the spring constant of the spring. We do this using f of x equals kx, where k is some constant. We plug in 9 for f of x, and the difference of the new length and the natural length, which will be 2, for x. We then find that the spring constant equals 9/2. We can now start on part A. Part A asks for the force applied on a spring with natural length of 6 inches to 10 inches. We first set up an integral with the distance started away from the natural length on the bottom, which will be 0, for the lower boundary. For the top boundary, we take the difference of the natural length and the final distance, which in this problem is 4. The integrant will be the spring constant times x dx, so 9/2 x dx. The antiderivative of 9/2 x dx will be equal to 9/2 times x squared over 2. We plug in 4 for x and get the answer 36 inch-pounds. Part B asks for the force from a length of 7 inches to 9 inches with the same spring. Since it's the same spring, the constant will remain the same, and thus the integrant. The top boundary will change to 9 inches minus the natural length 6 inches, which will be 3. The bottom integral will change from 7 inches minus the natural length of 6 inches to 1 inch. The antiderivative also stays the same, since the integral is the same, but this time we will plug in 1 for x, and we'll subtract that number from what we get when we plug 3 in for x. We will end up with 18 inch-pounds. And here are a few of Hooke's law's highlights. First, we must know the natural length and be able to find the spring constant in order to go any further in an answer. Second, we must be sure to put the right boundaries into the problem. Make sure you use the distance minus the natural length for both the top and the bottom boundaries. After that, it's just a simple integration problem. Thanks for watching.